Wrapping up this chapter, much briefer video this time, I think, is decision making. Overlaps quite a bit with everything we covered in the previous video about judgment. The technical difference is that most of the so-called judgment research is about estimating the probability or likelihood of something happening or something being true. And this is more about if you have multiple choices to select from, which choice do you think is the better choice? And some of the examples that I gave in the previous video fall under that category as well. I had an example of selecting a major, right? So there's lots of choices to pick from, and you got to pick one, right? So that's decision making here. So some of the same things when I've talked about rationality and heuristics and algorithms still applies here, but we have a couple of different things to cover here. So when it comes to evaluating alternatives, right, where I've got many different things to pick from or many choices here, uh, one way to think about what influences our decision here is called rational choice theory. And this involves calculating what is known as an expected value or EV. So the way I've framed it here is we have a choice, perhaps, right? Which is maybe I'm going to buy a lottery ticket. And I could choose to buy a lottery ticket with a jackpot of $1 million, or I could choose to buy a lottery ticket with a jackpot of $1 billion, right? And so we could ask the question, if you were forced to choose, right? Like if I told you, okay, the odds are the same and you can buy a ticket for $1 million or $1 billion, which one would you pick? Most people, I'm sure, would say, well, I'll take my chances at the billion instead of the million, right? But I want to frame this a little bit differently because this is a kind of behavior we see oftentimes in real world situations. We have lots of weekly lotteries that people can buy tickets for. We know that the odds of winning is incredibly low. And a lot of times, most people simply just do not participate. They do not buy these lottery tickets, even though the jackpots might be pretty high. They might be 20 million, 40 million, 60 million, $100 million, but they don't buy them. But then what happens is maybe every now and then some weeks go by and multiple weeks go by and nobody wins and the jackpots keep going up and up and up as they keep rolling that money over and over again to the next drawing. And pretty soon you see the jackpots inching closer to, say, maybe $1 billion. And suddenly everyone gets excited. And suddenly there's lines at the stores that sell lottery tickets because everyone wants their chance at this $1 billion now. And to an extent, it's understandable, right? That's a lot of money. But of course, so is $100 million. But that's beside the point. So can we try to understand why this happens, and is there any rationality to it? Well, let's see what rational choice theory says. So how do we calculate an EV or an expected value? What we're going to do is we're going to multiply the value of our win, right? Which could be, the size of the jackpot. We need to multiply that times the probability of actually winning the jackpot, and we have to subtract from that the cost of buying a ticket, which let's say it's a $2, right? I think that's the typical cost of a lottery ticket these days. I try not to buy them myself because I should know better, but every now and then, like everyone else, I might actually give in and do it anyway. So the rational choice theory says that we are more likely to select an option when the expected value is greater than one, right? So what would this look like? So I've got this worked out here. I had the number set up just so, right? So the probability of winning the lottery is incredibly small, right? It's 0.00, however many zeros there are there, dot, 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 342, right? So we need to multiply that times a million. That's going to shift over our decimal a few spots, right? So now down here, option one has the EV of 0.00342, right? So we moved that decimal point over a little bit there when multiplying times a million. And that gives us our value times P, right? And then we have to subtract from that the $2 cost of the ticket. And so we end up with an expected value of minus 2.00342. So what this is basically suggesting is that my expected value of buying this $2 lottery ticket is losing $2, right? Plus some fraction there, but it's essentially suggesting that I'm just losing my $2, which is quite likely to be true. But what happens when we have the $1 billion jackpot and we have to move that decimal over a couple more places? Then our value times P ends up as 3.42. And when we subtract the $2 cost, we still have a remaining number of 1.42. This value is greater than 1. And expected value theory says that we should be more likely to affirm, or maybe we should affirm. And that, of course, appears to be true. People do this. So does that mean that we're going to win the $1 billion? No. Does it mean that we're going to win $1.42 even? No, of course not, right? So does this high jackpot even increase your odds of winning? No, right? So one of the things we might ask here is that even though it might be more rational to if I was forced to choose, right? So if I was forced to say, hey, you got to take your choice. You're gonna buy a lottery ticket one way or another, but you have to take your choice between the chance at a million or the chance at a billion. The odds are the same. The cost of the ticket's the same. Then okay, sure, it's rational to pick the $1 billion payoff. But when it comes to just buying the tickets in general, right? You're not forced to pick between these two. Is it really rational to go out and buy tickets when these jackpots get really large? Since the odds remain still the same, infinitesimally small? The answer, I think, is no to that, right? Okay. Now we're going to move on here. I've had a lot to say in the first video about taking a more descriptive approach to human judgment and decision making. So one thing we want to focus on here is maybe moving away from situations like this lottery jackpot example here, where the numbers are quite clear and the numbers are quite calculable. And we want to focus on kind of real life decisions that we might have to make. Again, these kinds of ill-defined problems that I talked about in the previous video, where in the real world, our situations are much more ambiguous, and outcomes in terms of how we value these outcomes is also perhaps a little bit subjective and not so easily mathematically quantified. So that's the case again for that example that I gave for picking a major, right? How do I know it's going to be the right choice for me? Will I know when I take the first class in the major that I have selected? Will I know when I get closer to my senior year? Will I know when I graduate? Will I know when I get my first job, if I get a job, right? When will I find out whether I have made the right choice? And also, what are the exact outcomes that I am valuing in the first place? Is it my personal satisfaction and enjoyment over the classes that I'm taking? Is it my personal satisfaction and enjoyment of the job that I have? Is it the size of the paycheck that I get from that job, right? Where is the actual value? Again, that's going to vary perhaps from person to person quite a bit. So how do we calculate expected value here? It's not at all clear that we can do so. And on top of that, of course, the probability of any one of those outcomes being true is probably not even something we can calculate. In the previous video, I suggested that I could do things like calculate things like what's the job market look like and what's the salary look like. And those are all things that we can estimate. I would need to then evaluate the probability of actually getting that job after I graduate and the probability of getting that salary after I graduate. And that's a completely different question here. And of course, I also would need to put some sort of weight on each one of those, right? If I value the job satisfaction more than the salary, then that needs to factor into this choice a little bit as well. Or if I value the money more than the satisfaction, again, that needs to be factored in somehow. So it's not clear that we can do this kind of stuff, right? That we can even feasibly calculate expected values for these kinds of more ambiguous and ill-defined situations. What's even more telling, of course, is that, again, referencing heuristics and type 1, system 1 thinking, is there's this idea of deliberation without attention, that oftentimes when we are asked to make decisions, we really don't even think too much about it, right? And again, another example that I used in the last video was about picking a restaurant to go to. And sometimes we might have to sit around and deliberate, but maybe more often than not, we don't even do that. We'll just simply say, yeah, let's go to blah, 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 right? And we don't think about it, right? So there's no overt thought going on here. So that's very clearly a kind of a gut level response there. Now, there's one more thing that's maybe a little bit more critical for our current purposes here that I want to talk about this loss aversion and risk aversion. These are natural human tendencies, right? And these kinds of things are often not discussed when we see the economists talking about rationality, right? Being afraid of risk and afraid of loss, or some of those things that are sometimes considered to be irrational, because the part of the idea, like if you let's say, for example, if you are investing money in the stock market, you could be afraid of loss, and that might mean that you're going to take your money out at the first sign of instability, when most finance experts say that you just have to stick it out and you have to ride out these fluctuations in the market, and in the long run you're going to end up making money. And these things might be true, but at the same time, it ignores basic and real psychological forces that are at work in people, that we don't want to lose our money or any other thing of value to us. And that means we might not like taking risks as well. And these are, whether they are rational or not, these are real human tendencies. And it's also worth pointing out here that these change a little bit as we get older. So one of the things that there's a lot of research and aging research, developmental psych research, where we see that when we are younger, when we are in our adolescence especially, we might in fact be very, very enthusiastic about risk taking, right? High risk behaviors and risk taking behaviors are very commonly observed in adolescence. This maybe actually has a biological explanation, because there's evidence of some maturation and increased connectivity of these reward centers in the brain that involve the dopaminergic pathways that come from the substantia nigra through the nucleus accumbens and the prefrontal lobe and other frontal regions. These areas are maturing and developing, and there's a lot of connectivity changes in adolescence, and that increases our sensitivity to rewards. And that makes us more likely to engage in risk-taking behaviors if those behaviors might pay off with rewards. And so that makes us reward-seeking when we are young. But these same networks in the brain, they change and they decline in their sensitivity the older we get. And we see lots of very compelling evidence that older adults are the exact opposite. They don't like taking risks, and they don't like making mistakes. They find these things very aversive. So again, whether it's rational or not, maybe it's in fact a biological imperative with how our brains work, that there's going to be varying levels of tolerance for risk, and how much we seek rewards and gains, right? So these questions here about what is our tolerance for gains and losses, that's where we need to maybe think about this a little bit. Now, I've been mentioning economics here. So we want to make a distinction between classical economics and behavioral economics here. So here I'm calling classical economics a pseudo-social science. What does that mean? I'm not calling it a pseudoscience, but it's a social science in a sense, right? Because, it's about money, and that's usually thought of as a numbers game, but it's really about how people make decisions with money. So it does sort of border onto social sciences. So the pseudo is really applied to the word social here, not so much the science side of things. But again, there's a big, heavy emphasis on rationality in economic theory. But what you see here is that there's a whole field of research on what we call behavioral economics. Hold on. Getting up from my camera because I was just looking at this book prior to getting on camera here. One of my former professors wrote this book, Behavioral Economics, back in the 1980s. I worked in his lab for a semester or so when I was an undergraduate. And I didn't know anything about this until I started working with him. What's going on here is that he's doing he was doing rat research, right? And there's a lot of uh, graphs in here about observing. Can't find it now. Rat behavior in the lab, and like they're in the lab pressing levers, and we're looking at the rate at which they press levers, right? But one of the things he was doing in this research is he was um, trying to determine, things that are equivalent to like their wages for doing this work, right? So how many times do they have to press the lever to get paid? And getting paid means they get some kind of reward, like they get food. And so the idea of pressing levers to get food is this classic kind of Skinnerian reinforcement paradigm that we think about. But he was looking at it from the perspective of economics, that the rats are working and they get paid for working. And when we look at economic theory, there are lots of theories that have to do with things like wages and productivity and things of that nature. And it's applied to actual human workplaces. But Professor Allison here had the idea that we could use these same principles to explain, simple behaviors like that in the laboratory that have nothing to do with money, right? But still involve the same kind of general principles of doing something and getting something in return. And so there's lots of areas of life where these kinds of economic principles might still apply. But from that perspective, though, there's no particular assumption of rationality. It's really just about trying to show that these kinds of principles sometimes be usefully helpful in predicting rat behavior in those cases, but also human behavior in many cases. So what we want to do is we want to look at things like what is the perceived risk? What is the perceived gain? This is called prospect theory, right? How much am I going to gain? What are my prospects here of winning and getting some positive outcome? But of course, like things can also be framed in terms of losses as well. So that might have the prospect of losing something as well. And so this is where the issue of framing comes in, because framing means that if I am presenting choices to you, I can frame those choices in terms of what you're going to gain, or I can frame those choices in terms of what you're going to lose. And depending on that framing, that's going to have a big impact on your choices here. So here's an example. This is also in the book too, so you can go check out in the book here. So what we're looking at here is, again, we were faced with some choices, and depending on how things are framed, it's going to affect what people do. So this research was done before COVID, so kind of interesting. So we're presented with this imaginary scenario. Imagine the United States is preparing for the outbreak of a rare disease that is expected to kill 600 people, if only, right? So we have two alternative programs to combat the disease have been proposed. Assume that the exact scientific estimates of the consequences of the program are as follows. So on the left-hand side, we are framing them in terms of gains. If we adopt program A, we're going to save 200 people. So that's a sure gain. We're expected to lose 600, but program A will definitively save 200. Now, on the other hand, program B, if that's adopted, there's a 1/3 probability that 600 people will be saved and a 2/3 probability that no one will be saved. So while we do have a chance here of saving everybody, that chance might seem really relatively small. So which one would you pick? Well, what the research shows is the majority of our participants choose program A, right? Why? Because even though there's a small chance of saving 600 people in program B, there's also a pretty big chance we lose everybody, whereas program A is a sure gain. It's a sure win. It's not a complete win, but it still has certainty, right? So we've saved 200 people. Now what happens when we frame things in terms of losses? So on the right-hand side, we have two different programs. If program C is adopted, 400 people will die. Now, framing it as a loss, right? But one thing I want you to notice is that program C is exactly the same as program A, right? Because if there's 600 people expected to die, we can either save 200 or lose 400, but it's the exact same statement, right? But we're framing it differently. We're framing it in terms of 400 people are going to die. Now, for program D, now what we have here is a very similar kind of probabilistic statement. If program D is adopted, there's a 1/3 probability that no one will die. and a two-thirds probability that 600 people will die. So again, program D is pretty similar to program B in terms of the statistical outcomes. So do people pick program C here? Like they chose program A, and the answer is no. Now they prefer program D. Why? Because program C is framed in terms of guaranteed losses, and that doesn't sound so good. So when you read program D, you're thinking, oh, well, at least with program D, there's a chance that we can save somebody, right? Uh, so in fact, there's a chance we can save everybody. So that's the idea here, is that when we are presented with sure gains, we prefer the certainty of the gain over the uncertainty of even better gains. That's why people choose A over B. But when things are framed in terms of losses, we prefer the uncertainty of a loss versus the certainty of a loss, right? Maybe an uncertainty of a larger loss over the certainty of that 400 loss, right? So again, we see that it's equivalent options here, but the framing matters, right? So that certainly affects people here. But again, I'm suggesting that this is part of the way we naturally think about outcomes here. The rationality issue is critical here because while these might seem irrational, what we need to think about here is that the loss aversion, the risk aversion, is an emotional response. And we might think, okay, what are we supposed to do? Are we supposed to be like, I'm going to show my age here. I'm going to talk about Star Trek and Spock, right? So I'm going to say, am I supposed to be like Spock and not let emotions cloud my judgment? That's a phrase people say quite a bit, right? Don't let emotions cloud your judgment. But the reality is that humans are inherently emotional animals, right? We are not computers, as I've said before. And it might be that having emotions plays a very critical role in our judgments and our decisions here. And it might actually be a good thing. So, this idea that people say emotions can cloud your judgment might not be as true as it sounds, right? It might be that emotions are aiding your judgment because emotions might help you really account for the negative consequences of an error, right? If I make the wrong choice, if I make the wrong decision, there's going to be a negative outcome possibly. And it's one thing for me to shut off all of my emotions and say, okay, but I don't care about that negative outcome. I'm not going to let the amount to which I care influence that. But the reality is that we do care, right? And being able to anticipate the negative emotions that might follow such mistakes, if we were to make them, is going to have a definitive effect on our judgment. And maybe that's informative. Maybe that's relevant after all, right? So here I have some research that is in that vein, right? This is called neuroeconomics now because we're just going to slap the prefix neuro into anything and make it sound cool, right? But what we're doing is we're looking at brain activity while people are engaged in these kinds of behavioral economic kinds of choices. And so what we see, of course, is that, yes, emotion centers become active in the brain during certain kinds of decision-making processes, especially ones that are framed in terms of gains and losses, right? And especially when they're framed in terms of losses, there's going to be activation of some of these emotional centers that are related to negative emotions. I already mentioned the nucleus accumbens as a reward center that helps make us seek rewards and so forth. But let's talk about these moral dilemmas. On the right, I have three pictures here of two of them are the famous runaway trolley car problem, right? So you're supposed to imagine that you are the person in the yellow shirt. If you can see that on your screen there, there's a runaway trolley car, and it's going to run over these five people who are irresponsibly hanging out on the tracks. I have no idea why they're hanging out on the tracks, but that's what they're doing. And so you happen to see that there's this runaway trolley car, and it's going to barrel over these people and presumably kill them all. So we got to do something about that, right? What are we going to do about that? Well, we can't yell out to them, right? So the way the situation is set up is that they're too far away and they're not going to be able to hear you, so you can't warn them. But what you can do is you happen to be standing next to a switch, and that switch will reroute the trolley car to a different spur, and now it's going to take a different route, and you're going to save those five people. But oh, there's another person, the person in the green shirt there, who happens to be just by themselves. And again, loitering irresponsibility on the tracks. So is it better to kill the one instead of the five, right? That's a utilitarian answer here, of course. But the idea is, regardless of which you choose, of course, part of the challenge here is that even though fewer people are harmed if you reroute the trolley car, what happens is that it's because you have to make the choice and you are actively doing something. So if you don't do anything and you're just like, hey, I wasn't involved. This is not, I'm not the reason that this happened. My passivity results in those five people getting hurt. But in order to save them, I have to actively do something. I have to hit that lever, but that's going to then affect that other person who would have otherwise been unharmed. And so that is where the dilemma starts to become a little bit of a bigger challenge for a participant who's asked such a question. And philosophers are interested in this from the ethical perspective to understand what kinds of ethical systems are at work here and what kinds of things factor into the ethical choices people make. But from a psychology and a neuroscience perspective, we want to know, how do people feel about it and what's going on in their brains. The second one down is one where things are a little bit more direct here and active, where instead of flipping a switch to reroute the trolley, there's this guy in a purple shirt, and you're asked whether you would push him over the side of the bridge so that he falls on the tracks and blocks the trolley, right? So that's a pretty bad thing to do. There's a variant where you're stuck on a life raft here with some other people and it's shrinking, and now your task is to throw somebody overboard. Again, it's that poor person in the green shirt who you're going to throw overboard. So would you do that, right? What we find is that when we look at brain activity, it activates the prefrontal cortex, right? PFC. And that makes a lot of sense because that's our reasoning and judgment centers of the brain. But amygdala and cingulate gyrus, these are in the limbic system. These are the emotional centers, right? The amygdala is associated with fear and negative emotions. The cingulate gyrus is part of a error detection system, right? Where we're trying to anticipate the likelihood of making certain mistakes and then what are the negative consequences of these mistakes. Also, of course, helps us to evaluate the potential rewards associated with certain behaviors as well. So all of that stuff here about the consequences of our action and the costs and the benefits, as well as the emotional side effect of all of it, these become highly active. And there's no way to turn this off. So whether, again, we want to call this rational or irrational, it's the reality that human cognition and human emotion are intricately bound up with each other. And so there's no point in acting as if we could ever dissociate these two things because we are not robots like Data in Star Trek or Vulcans like Spock in Star Trek, right? We're humans, and I think there's a note somewhere in your textbook about what's the role of emotion in cognitive psychology and how come there's not much content about emotion. And that's because in traditional cognitive psychology of the kind of stuff we've been talking about, most of that emotional stuff has been treated as something that's messy and weird and hard to integrate with our theories of information processing that tend to focus on brains like they're computers. And then once we start throwing in emotions, it starts to become really hard to continue to explain information processing in the brain. All that stuff we talked about in the very first chapter, right? So my little soapbox that I'm on here right now is that we really probably should try to get away from that perspective and focus more on where the emotional stuff really comes in and what's it doing and why do we have it in the first place. And it's probably a very ancient part of our brains that plays a pretty critical role in influencing all of our judgment and decision making, and it probably plays a very valuable role in influencing our judgment and decision making. So we should recognize it as such. I will get off my soapbox. That, I think, is the last slide. That's correct. So that's it for this one. I'll see you in the next chapter.